Hello, welcome to Hell is Other People's Code. Today I'm going to talk to you about software supply chain security. My name is Laura Thomson. I'm the VP of Platform Engineering at Fastly. Fastly is an edge cloud platform, and platform engineering means I look after everything from the edge back. So today I'm talking about supply chain security. I'm going to start by telling you that this talk is not actually aimed at security professionals. It's aimed at engineers and engineering leaders who want to do a good job with security, especially supply chain security. I'm going to start by telling you what it is because not everyone is clear on that. You may have heard it being talked about with that sort of, I don't really know what that is, but it sounds like something I should be scared of. I'm going to tell you why you should care and why you should want to do something about it, and then I'm going to tell you what it is that you can do about it, even though it sometimes seems overwhelming. Supply chain security activities aim to enhance the security of the supply chain or value chain, the transport and logistics system for the world's cargo. So this is the generic definition of supply chain security that has nothing to do with software. And when you're thinking about the world's cargo, we're talking about like shipping containers, and you might have something in mind like pirates coming to intercept your cargo and run away with it, which is really not the issue that we're dealing with here, although we do obviously deal with piracy in software. Interestingly enough, if I keep reading that Wikipedia article about supply chain security, once I look at the activities that are involved in it, it starts to make a lot more sense in terms of software. So if I was thinking about cargo, I would care about things like credentialing participants in my supply chain, making sure everybody is who they say they are, make sure they know what they're supposed to be doing. Screening and validating the contents of cargo being shipped, making sure that there's nothing malicious in those crates. Advanced notification of the contents of the destination country, so you're getting things you're expecting to get. Ensuring the security of cargo while in transit via the use of locks and tamper-proof seals. Yep, that sounds like something we do in software. And finally, inspecting cargo on entry. So, okay, I'm starting to get some context here. It's good that it's starting to make sense. And here's a formal definition from GitHub of software supply chain. I want you to think broad when you're thinking about supply chain security. So a software supply chain, anything that goes into your code, every line of code, everything that you use to produce your code, from development tooling through your CI and CD pipeline until it gets deployed into production. It's as broad as you think is probably not broad enough. So that's one of the messages I want to tell you today. Okay, so I'm going to try and explain the threat model in a very generic way. When we think about security, we might think of, our company as a castle. And the traditional thing that you might think about as an engineer when you're thinking about protecting against security threats or attackers is you're thinking about enemies at the gate. There's a couple other things that you might think about if you're a little bit more sophisticated further down the path in terms of thinking about security. Hopefully you're worried about insider threat. And that is somebody inside the castle who opens the gates and lets the enemy in. Supply chain threats in this context are, someone who has poisoned the well inside the castle or, infused the grain with ergot or something so the army can't fight. And that is really what we're talking about when we're talking about supply chain threats. So what does that mean, and why is she talking about pirates and castles? So examples of this would be things like third-party open source libraries, which we almost all use, right? More than 80% of software out there has some kind of open source in it these days. It might be any tools or software as a service that is used in your software, to host your software, to produce your software, or to monitor your software. So that includes continuous deployment, includes source code hosting, includes monitoring tools, observability tools, any of those kinds of things. It also includes things like the infrastructure, the hardware that your software runs on. What is the firmware that's running there? What is the operating system? What is the kernel that you're using? It also means the security of any signing keys that you may be using, which I'll talk about later. So it's basically turtles all the way down. You need to worry about security at every level of the stack. So sometimes it's said in the open source world that we stand on the shoulders of giants. But what do you do if the giants are untrustworthy? The question you might be asking yourself is, why should I care? This all sounds like something very vague and hand-wavy, and I don't see that I can care or do anything about it. I'm going to tell you some stories. I always think the best part of security engineering is the stories we get to tell. Okay. So one way of thinking about this whole concept is don't ship malware. This came up. I once worked on a project with Richard Barnes, who is a crypto enthusiast, as he described himself. He used to be a principal engineer at Mozilla, where I worked with him, as now at Cisco. And we had this project where we were trying to look at all of our systems and try to figure out where the cracks between things might be. Where were the overall risks, the weakest points? Where was it brittle from a security perspective? And explaining this to people was really hard. There wasn't a good elevator pitch for it. People would be like, I don't understand what you're doing. It sounds very broad. And at the end of the day, it came down to this aim of like the software that we produce, that we ship to end users, shouldn't be malware and shouldn't contain malware. So don't ship malware. There's actually stickers of this somewhere, very unofficial, going around. Okay, So let me tell you a story to motivate this. This is actually not really, strictly speaking, a security story, but it is a supply chain story. You may remember a few years ago now, there was some problems with LeftPad. This is back in 2016, so about 5 years before I'm giving you this talk. LeftPad is a small node module. There's 11 lines of code. And actually, if you look at this slide, you can see the text of the code there. It's really short, right? Like this, it does very little. And what happened was that the person who made this library had, a problem actually with one of their other libraries, a disagreement, and they were upset about it, and they pulled down all of the libraries that they worked on, including this one, which was actually not the one that was contentious. What happened then was that thousands and thousands and thousands of software projects broke because they were all depending on this thing existing. And when it didn't exist anymore, we had real problems. So that probably should have been an omen that people paid attention to. But, we tend to go, wow, that was really bad, and I'm glad that wasn't me. Or, that was me, and that was really annoying, but it's fixed now. And, I've replaced that 11 lines of code, and I don't need to worry about it anymore. 2 years later, in 2018, we had this problem with EventStream. So this is a long and complicated story, but EventStream is in fact another node library. And the person who was the open source maintainer had somebody else volunteer to contribute to it. And the person who was contributing pulled in another dependency. And at some point, that other dependency was replaced with malware, which meant that the malware ended up in EventStream, and it ended up in all of the code that uses EventStream. This is really, really scary at this point. Because at this point, you have someone way up the value chain has introduced malware, and now it is running on hundreds of thousands of computers worldwide. I like that the issue here is I don't know what to say, because that is how you would have felt in this situation. Okay, more recently, as recently as December, you probably saw stories about this because it was everywhere. This had a really high impact across a lot of really well-known companies, a lot of really well-known governments. But a particular tool was used to compromise multiple victims. And somewhere along the line, the code for this tool had been infiltrated with malware, believed to be from state actors, which is, if you're not in security, means like people from other governments. This is really bad for obvious reasons. Okay, but you'll see there it says it leverages supply chain to compromise multiple global victims. From the point of view of an attacker, it's very desirable to do a supply chain attack because of the amount of leverage that you have. Instead of spending all day attacking one company, if you attack the supply chain, you then get for free access to all of the companies downstream from that. Okay. If you deal with this on a day-to-day basis, you might say something like, well, there's this repo of CVEs, over at MITRE, they keep track of them all, it's in a database, and when one of these things happen, like this one, which is, a CVE in Kubernetes, I might, somebody from my security team will ping me and say, hey, you need to upgrade Kubernetes. And that's really it. I don't really see why that's such a big problem, right? Great, problem solved. The thing that often happens, though, is that real world basis, you get a little ping on Slack and it's your boss saying, I saw this Meteor article about a software problem in this third-party tool or third-party library. Are we affected? How easy would it be for you to answer that question right now? Do you know every tool that's used everywhere in your organization? If it's an organization of one and you're the only person that works there, maybe you do. You maybe haven't thought about it. You might not know all of the software that's running on your laptop. You might not know all the software that's running on, wherever your software is hosted, if it's running in a third-party location like in a cloud. You probably don't know where all the pieces that make up your operating system came from. So you probably don't know if you're affected off the top of your head. And that's really scary. So when you start thinking about it like that, your boss coming and saying, are we affected? And you can't even answer the question. Like, it's not as simple as patching the thing. You don't know what it is to patch. You don't know where to patch it. You don't even know if it's in your code or somebody else's code. So at this point, it starts to seem like a garbage fire, right? An unavoidable disaster of truly epic proportions. This is a garbage fire in a garbage truck that's going at high speed towards an even bigger pile of garbage. So before we talk about what we can do about it, let's think about how this even happens. How do we get here? So there's kind of three main points that I want to make to you today. One is that the first way that these kind of supply chain attacks happen is through indirect approaches, which means that something upstream of you has a vulnerability, right? So maybe it's a vulnerability in your operating system. Maybe it's a vulnerability in your node library. It doesn't really matter what it is. And that is something that has yet to be exploited, right? So that is something that could be exploited, but you don't know if it has been. The second kind of attack is a direct attack. So this is somebody who has deliberately implanted malicious code upstream from you. They are hoping that it will get to you and cause a problem for you, or that it will give them access to your systems, right? Whether that be the data that you're storing, that belongs to your end users, or to your code, your IP. Maybe it's access to the video cameras in your data center, right? Like that is the intention there. Someone has planted malicious code and is hoping that they will get some effect from it. The third thing here is that, as well as sort of indirect vulnerabilities and direct attacks through the supply chain, you want to not be the person that's responsible for this. At the end of the day, when CVE comes out, you don't want it to be in your software. If you are seeing some press release about here is this third-party tool that caused vulnerabilities in lots and lots and lots of websites, you don't want it to be your fault. So these are kind of the three threats that we need to think about and how we would mitigate these. So when I say upstream, what do I mean by upstream? I mean things like third-party vendors and suppliers of all kinds with physical or virtual access to software. So when I say suppliers of all kinds, what do I mean? So think about your data center. Even if you are using a cloud provider, there's a data center somewhere. As we say, the cloud is just another word for somebody else's computer. And somewhere in that cloud, there is a data center with a computer in it. Who has access to that computer? Is it in a well-secured cage? Can anybody from the janitorial staff all the way up through software engineers who are SSHing into boxes access it? Right? There are a lot of people who can touch the software that you're using. Do you trust them all? Who are those people? How can you trust people when you don't even know who they are? What else is upstream? Any kind of software that you're purchasing from suppliers, any kind of hardware you're purchasing from suppliers, those actual computers that you bought that come with firmware installed on them. Do you trust the people that wrote that? There's all the open source libraries. You have slightly more direct control over that, but it still starts to get combinatorially complex very, very quickly. Your data storage providers. And once you start thinking about it like this, and you're like, I have to worry about somebody that is sweeping the floor in the data center on like some part of the country, I don't even know where it is. Can I trust that person? And the answer is you can't. The list is endless. And this is a point where people sometimes start to freak out. So if you haven't started freaking out, here's some things that'll make you freak out a little bit more. Some scary numbers. These are from GitHub's annual Octoverse report. So if you look at the right-hand side, they have done an analysis of all of their repos and show you what percentage of the repos in each of these languages rely on open source libraries. And what you can see just from glancing at it is that more than 80% of most applications code is from the dependencies. So most of the code that you have is not the code that you wrote, it's the code that somebody else wrote. So for example, if I think the average here for a node repo is that there will be on average 683 average transitive dependencies. And by transitive, I mean not just the libraries that you include, but the libraries that those libraries include and so on. Okay, so now you're scared. Don't be scared. That's not super productive. It's good as a motivating force, but you have to turn that fear into doing something constructive. So I think the very first step is to map the territory, monsters and all. I love these old sea maps that show, there's a sea monster here and there's a sea monster there. Sometimes I think of this as here be dragons, right? So the very first step to take is know what you're dealing with. There's just some basic advice here. Is really you need to take an inventory of what it is that you have. The thing to remember here is security is always a process. This won't be done. Even if you sit down and make a list of all the things that are components, first of all, it's going to be very long. And second of all, it's going to be changing. It'll be out of date before you even finish it. One of the things that's important is to realize that thinking about it as a whole system is fundamental to any kind of success here. So think about all of the components of the system and how they interact. And probably most importantly is try to think what the threat model might be for your company specifically. If you make software that ends up on the computers of end users, then somebody that's attacking you is hoping to get access to the machines of those end users. If you are a software as a service provider, then they're again hoping to get access to your customers, access to you. If you work for someone that has really interesting data, right? What are the things that those people are coming to attack, and what is the way that they are most likely to attack it? The more you understand the threat model, the easier it is to defend against it, because you're not trying to defend against everything, because that is insurmountable. Okay, so first we talked about direct upstream attacks. In order to mitigate these, there are a few things you can do. A lot of it is around what I would describe as vendor qualification. So when you are actually paying somebody for software or hardware or firmware or whatever it is, you should make sure that you have security requirements in your request for proposals and any contracts that you have. So at least you have some kind of legal protection. You should vet and qualify the vendors. And you can do this by doing sort of a security questionnaire, looking at the vendor's practices and so on. There are, on NIST's website, there is a pretty good checklist of things that you should ask a vendor about. The third thing is you have to be willing to replace a vendor. If somebody has ongoing problems, be prepared to switch. I think that's really important. Or if you are going down sort of this purchasing path and somebody isn't passing qualification, then start looking at other vendors. And finally, track the provenance of everything that you use, right? Make sure you know have an inventory of all the things that are used in your software, and keep that up to date. In terms of indirect attacks, again, know what you have, including those also ephemeral transitive dependencies. Make sure you keep up with patches. So for all the things you have, patch when there's a CVE, patch when there's not a CVE. It's really important to have like a regular cycle for patching. If you work for a big company, it'll be for compliance reasons. If you don't work for a big company, make sure you're patching operating systems, libraries, languages as often as possible. Maybe it's a weekly cadence, maybe it's a 30-day cadence. And obviously when you have security problems, you would patch them on the day if you could. The other thing is, as you get these controls in place, at the beginning, you're hoping to go from sort of auditing and monitoring what's in the supply chain and making sure that it's keeping up to date to some kind of actual enforcement, and that could be through process or tooling. Finally, the third big thing is don't be the entry point for malware. This is just general adherence to good security practice, but specifically around your code pipeline. So here are some examples of things you can do. One thing that I've had good success with in the past is using a two-person rule. And that can be a two-person rule for access to systems. For example, getting into a data center cage. It can be two people required to commit code. So what I mean by that is that something must have passed code review from a second person before it can be committed. Again, to something pretty easy to enforce with tooling. For deploys, it is good to have somebody to ask for the deploy and somebody to approve the deploy. If you want to go like fully down the path that sort of the financial industry has, is you can enforce that those two people are not in the same management chain, which is harder to do. And I would only suggest going that far if you had sort of extremely sensitive environment. You want to make sure you have authorization for all of these things. So not just two people, but two people who are on the right ACL, like that are allowed to do those things and that they've had to log in to do them, and an audit trail so you know who did what and when if you have to track something down afterwards. One thing that I see that people often fall down on is use of internal tools. People sometimes have very good security around their production systems, but they're like, oh, well, that's just the CI pipeline. It doesn't matter that the operating system is 9 months out of date or 3 years out of date or whatever it is. But honestly, they require the same attention to detail as production systems. You might think they're not public facing, but if somebody has entered your systems, it would be better if they were in fact up to date and not vulnerable to those kinds of problems. In general, basic security principles like limiting sideways movement between systems. So if somebody comes in, through the front door, they shouldn't be able to easily get into your release pipeline. You have to think about things like code signing, like this code came from me, so that people can verify that it's not from somebody else and it hasn't been tampered with. And whatever other appropriate use of crypto is appropriate for your environment. So to summarize, in any kind of security problem, there's never a magic bullet, right? You can't. I think sometimes people are like, I wish I could just buy a piece of software as a service that would solve this problem for me, track all my dependencies and update all my software and deal with it for me. There are some tools that will help with dependency tracking, but as we've discussed, that's really only one piece of the puzzle. So what you really need to do to approach this problem is just have an accumulation of good practices. Track your dependencies, have good code hygiene, have good visibility to what it is you have, make sure your developers have good education on how to produce secure software, and keep doing those things over time, and it will get better. Probably if I could leave you with one key takeaway, make sure you think deeply about what the threat model is for your environment, and understand that and protect against those things first. That's it from me. Thank you for joining me.